Welcome to OpenEdge Database Monitoring, Obscure Minutia. In this session, we're going to talk about some of the more obscure and lesser-known metrics that you can monitor that may help to keep you out of deep trouble. This will include some stuff that you would really prefer not to learn about the hard way. I'm Tom Bascom. I've been a Progress user, coder, and roaming DBA since 1987. Here at White Star Software, we specialize in simplifying the job of managing and monitoring the world's best business applications. We're also the author of Protop, the best OpenEdge monitoring tool in the galaxy. We offer remote database management services for OpenEdge and expert consulting services related to all aspects of Progress and OpenEdge. If you'd like to reach me for any reason, email me at tom@wss.com. Thank you, and let's get started with today's presentation. Protop is, of course, a very helpful tool for keeping track of these obscure details. All the Protop screens that I'm going to show you are part of the free real-time monitor that you can download for your system. If you do not already have Protop installed, go to wss.com, select the appropriate package, and follow the installation instructions. The real-time monitor is absolutely free and needs no special permissions or access rights beyond what you have as a DBA for your system. You can optionally set up access to the free version of our web portal for pretty charts and graphs if you like that kind of thing. And if you're interested, you can contact our crack sales team for the complete monitoring and alerting package. Protop has a lot of features to explore. You can easily get an overview of those features in the real-time monitor by pressing the question mark or H keys to bring up the main help screen. A lot of obscure issues are related to the configuration and usage of storage areas. Every storage area has a maximum area size and a maximum number of fragments. The maximums depend on whether it's a type 1 or a type 2 area, whether you have 32-bit or 64-bit DB keys, and what the rows per block settings are. There's also an index alignment bug in some versions of Progress that can crop up and bite you, and you want to avoid having user objects in the schema area. You also want to generally avoid mixing indexes, data, and lobs in the same area. And individual extents can have a size limit depending on whether you've got a workgroup license or an enterprise license, and whether or not you have large files enabled. The Protop storage area information screen is accessed via the A command, and this draws your attention to a lot of these issues by color-coding metrics that you might be interested in. Right away, we see that there are some things in red. We see that in this particular database, the allocation is well over 100%. So we started out with a fixed allocation of extents, but we've allowed the database to grow into the variable area. This is actually quite common. A lot of people start out with the idea that they're going to manage the extent sizes, and then over time they stop doing it and the extents grow into the variable areas. We can also see really quickly that there is an area with a cluster size of 1. This is the schema area. Unfortunately, the schema area has to have a cluster size of 1, so it is a type 1 area and cannot be a type 2 area. And then we see that there's a little asterisk over in the note column. And what that means is that there are user objects in the schema area. And what we see here is that there are 2 indexes that are in the schema area. On the bright side, we see a lot of green. Most of the storage areas are type 2 storage areas because they have cluster sizes larger than 1. And we see that for the most part, we're not mixing tables, indexes, and lobs, although there is one storage area where we have a lob mixed in with a bunch of data. So that's something that we might want to address. We're nowhere near the maximum size for these storage areas. These are all type 2 storage areas. So as you look at the maximum percentage, we're very small. And our high water marks are relatively modest. So we got a lot going on, but not a lot of bad stuff, just a couple of things. Details about individual extents are shown on the File I/O and Extent Info screen, which is accessed via the F command. This is an enterprise database with large files enabled, so 2 gigabytes isn't a problem, and we're a long ways from getting towards 1 terabyte. But Because large extents can be kind of a hassle to deal with, it's nice to know when you have something that's a little bit bigger. So we are showing in red some extents that are more than 16 gigabytes in size. We have a couple here that are in the mid-20s, 26 and 25 gigabytes, another one that's just over 16. And that's a little unwieldy and kind of a pain in the neck. So we probably ought to set those to a fixed size and then move into a new variable extent. The After Imaging info screen, reached with Control-A, shows details about the size and the status of after-image extents. This is a post-10.2b database, so we don't need to worry about the sequence number. But something that's very interesting to pay attention to is the time needed to copy a full extent to the archive location before it gets marked as empty. On poorly performing disk subsystems, this time can start to cause problems, potentially resulting in locked extents or a stalled database. In this case, 12 seconds to archive the extent is good. 5 minutes would have been pretty ungood. You can also get this information by looking in the log file and examining the time between the two messages 3777 and either 3789 or 13199, depending on what order things happen in your particular database. Sequence activity can be another place where obscure things happen. Sometimes people forget to change old limits from back when they had 32-bit databases, and so you'll have a sequence maximum that's much lower than it could be. Or you may have a workflow system that has very, very high activity using sequences to control things. And you'll see this sometimes with users that are blocked on resource 192. Interestingly, in this case, there's a fax sequence number, but it doesn't seem to be used anymore. So hopefully that means that somebody got the memo about fax machines all having died off 20 years ago. The Login Brokers screen helps you to quickly see the configuration of the brokers. This helps you to quickly determine if you might need to adjust any of the client-server configuration parameters, things like the number of servers per broker or the number of connections per server. The server activity screens below show what's going on across all the servers on the 9999 line, as well as individually showing the busiest servers. One of the obscure issues that you might run into with client-server connections is that the number of messages can saturate the NIC just as easily as the number of megabytes does. So you need to be aware of both the volume in megabytes that you're sending across the link, as well as the number of messages, because the Progress client-server protocol is very chatty. And this is especially a problem if you're in any kind of a shared or a virtualized environment, because your usage may be just a fraction of what the entire usage on the network is. And when you start sending a lot of data, you're going to have a much bigger impact. In this particular case, if the client was on a 10 megabit network, they would be getting pretty close to 80% of the capability of that network. And that would be a problem. Luckily, they have a much faster network than that, so that's not an issue for them. Protop can also show you some pretty interesting stuff about SQL activity. The uppercase Q command, be careful, lowercase q quits Protop, but uppercase Q lets you see SQL activity if the client statement cache has been enabled. This allows you to see what statements those clients were running. Sometimes that can be really interesting, especially if your users are swearing that they're only running reports and you see that they're updating data. That's kind of curious. Oh, look at that. We're locking records. We have transactions. How can that be? The buffer pool screen is a pretty interesting one. This is new with 11.7, where you can get data individually for the primary and alternate buffer pool, which breaks out certain things like the number of data blocks and index blocks. One of the obscure issues that you can see with buffer pools is sometimes you have unused buffers, which is wasted memory. In this particular case, we see that 1 million buffers were allocated to the alternate buffer pool, but they're not being used. So this is about 8 gig of memory being wasted on this particular server. If you look at the buffer pool data, it can be really kind of interesting to see the ratio between data blocks and index blocks. In this case, it's about 10 to 1, 9 million to just under 1 million. If you are using the alternate buffer pool, you would generally not want to see any I/O because the point of that is to avoid LRU references. And if it gets to a point where the data is bigger than what you've got allocated, then you're going to have swapping in and out, which means that you'll have to account for the LRU chain. If you see any kind of OS read activity on the alternate buffer pool, then that tells you that it's too small. So you should basically always have at least a couple of unused buffers with the alternate buffer pool, but not, a really large number like what we see here, which is primarily because we're just not allocating anything to it right now. Another screen that can show some pretty interesting obscure information is the table, index, and user activity screens. Now on these screens, what you generally see is the highest activity table, index, and user entries. So you'll see the most active table, the most active indexes, and the most active users. And that's interesting because it helps you to zero in on places where you might have performance problems. But if you look at some of the other data that's shown on those screens, other than just the raw number of reads and writes and things like that, you see some other stuff. For instance, in the table information, you see that there's a red metric here for fragmentation percentage. That means that the records within the carrier table are fragmented 6.5% of the time, or basically a little less than 1 out of every 10 reads that you do, you're going to do an extra read. So that's extra I/O that you didn't have to do. You also look and you see this column for churn. So we see that the loc group table is being churned 20 times. It's a table, it's a very small table. It only has 38 records, but we're reading it the equivalent of 20 times per second. So we're reading that entire table over and over and over, or the equivalent of the entire table. We might just be reading one record even more frequently. You can't really tell, but we do know that there's enough activity there to turn that whole table over 20 times per second. If you look at the index activity, you'll see that there's a column called utilization. And this is a measure of how well the index blocks are being filled. So if you see that index blocks are only about half full, that means that an index compact operation could improve your performance and reduce unnecessary I/O operations. Generally, we only do that for tables that have more than about 1,000 blocks. So you wouldn't really care too much about the carrier table or the loc group table because they only have 8 and 1 blocks. But this SCRM valid queue table has 12,000 blocks, and it's only about half utilized. If you compact that, then it will only need 6,000 blocks, and it will be much more efficient to access. Another thing to think about is whether or not the number of reads between the table and the table's indexes are balanced. As you see here, we have the SCRM valid queue table being read about 93,000 times per second. That's record reads per second. And the index reads are very similar, also about 93,000. That's normal. That's what you want to see. Although the rate of reads is rather high, the fact that they're balanced, that there's one index and that you're reading an index entry and then you're reading a data entry is what you want to see. Sometimes you see a situation where it's not balanced, where you have many, many more index reads than you do record reads. That's an indication that the where clause is not very efficient, could be improved. Or you may occasionally see a situation where there are a lot of record reads, but no index reads. That's a table scan. If it's a 4GL program, it's using the table scan option. If it's a SQL program, then it's using the SQL table scan. And that's good. Well, at least it's good if that's what you intended to do. It's not always good to be scanning the entire table if you didn't intend to do that. Even a simple backup reveals a host of interesting and obscure information. For instance, as you probably know, the log file will tell you if the backup was successful or not. It will also tell you how much space the backup needed, how big the resulting backup file was. It'll tell you how long it took, as well as how long the BI phase of the backup took. From the data that you get in the log file, you can also derive some interesting things, like how much space was saved by the -com option if you used it, or what was the backup block size. The time that the backup takes is also interesting. You don't want that to overflow into your working hours. One of the things that is often the first indication of I/O problems is the time that it takes for the BI phase of the backup to complete. If the BI phase is completing relatively quickly, then you probably have no issues. But if it is taking longer and longer and becoming a problem, more than a few minutes, then you know that either the BI file has grown very large or there is pressure on the file system that holds the BI file. And that can be a very useful early indicator that you have performance problems in your storage subsystem. Quiet point requests are another area where some obscure problems can happen. One thing that people often overlook is that proquiet is not an immediate command. That is, proquiet is just a request to the database service manager to quiet the database. You have to monitor the log file to see whether or not the quiet point has actually taken place before you can take advantage of it. So if you're scripting something to do something like make a backup after you've quiesced the database using operating system tools, then you need to both ask for the quiet point and confirm that it has occurred by looking in the log file for the quiet point has been enabled message. Likewise, when you disable the quiet point and re-enable the database for activity, it's also just a request. So you have to monitor the database log and make sure that it's in there. One thing to watch for, if you're doing this in a scripted manner, so maybe you're doing a quiet point every night while you do your backup, is to make sure that the time stays consistent. If this time starts to grow or varies wildly, then any assumptions you've made about, well, it always takes 5 seconds or something along those lines becomes invalid. Another reason why you have to watch for the message. You also want to pay attention to the trend because over time, much like with the growth of the potential growth of the BI backup phase, if things start to change over time, then you probably have a pending performance problem, and it's a little bit of a canary in the coal mine that you can use to head that off at the pass. So to summarize, you now have a sampling of obscure minutiae that you can avoid stumbling over, and some tools to help you sniff out your exposure to these sorts of problems. Thank you very much. And please, if you have any questions, join us in the chat window or send an email to tom@wss.com. Thanks again, and we'll see you in the chat.